Okay. Good afternoon, everybody, and welcome to class. Today we're going to be identifying primates. And there's a couple of learning objectives I want everyone to pay attention to. And the first is to understand what a primate is and how we evolved. And this is important to know because we ourselves are primates. So if we want to understand our own evolution, we need to understand primate evolution as well. And to better get at this question, we're also going to learn how to recognize some physical traits that are unique to primates. And then finally, using those physical traits, we're going to identify primate versus non-primate animals. So the first question I wanted to ask anybody or everybody is, what is a primate? Does anybody know what a primate is?
An ape, a monkey,
Apes, yeah.
an orangutan, a gorilla.
Perfect. So all of those things are primates. And as you can see by all of the pictures I have here, the primate order is an incredibly variable and diverse order. It's a very large order of mammal that appeared about 56 million years ago. And all of us share a number of the same physical traits. That's what makes us primates, are these physical traits that we all share. And primates include lemurs, lorises, monkeys, apes, and humans. And does anybody know any primate traits off the top of their head?
Fingers.
Fingers, perfect. Yeah, fingers are great. Any others?
Tails? I don't know.
Some monkeys have tails.
Pregnancy,
Yes.
They only have one baby at a time.
Some do. Primates do have a lot fewer offspring, so that's another primate trait.
They're the closest to humans in the amount of genes.
Also true. Yeah, genetically speaking, we are the most similar. So yeah, great. These are all perfect traits to talk about when we're talking about primates and primate evolution. All of the ones you've mentioned are ones we can see in living organisms usually, or by using molecular data. But the ones we're going to talk about today are skeletal traits, particularly traits that we see on the skeleton, and particularly or specifically the ones we see on the skull. And there's two big ones I want you guys to learn today. And the first one is forward-facing eyes. So I have two skulls here. The first one is our primate skull. This is a male gorilla skull. And you can see the two eyes, we refer to them as orbits or eye orbits when we're talking about the skull, are forward-facing. And you can also see that on yourself. So if you're just looking in the mirror, you can see your two eyes clearly right on front of your face. Whereas if we look at this skull, the non-primate skull, this is a horse skull, the eyes are laterally facing, or they're facing on the outside. So they're oriented on the side of the head. So this is one big trait that primates all share, are having forward-facing eyes and not eyes that are lateral. The next one is called a post-orbital bar. So this is another trait that's related to our eyes, but you can see it in this picture of our primate. It's this bony margin or border that you see right along the sides of your eyes. And if you feel it, if you take your fingers and put them on the sides of your eyes, you can feel your postorbital bar. So this bony bit right here is your postorbital bar. And that's another trait that all primates share. If we compare it to our non-primate, this is a grizzly bear. Do you all see this gap between the top of the eye and the bottom of the eye? Yeah, so there's no postorbital bar on a grizzly bear. But it is important to note that a grizzly bear has forward-facing eyes. So grizzly bears have forward-facing eyes, but no postorbital bar. And if we go back to our first slide, you'll notice that there's actually a bar on the horse. So the horse has a postorbital bar, but does not have forward-facing eyes. So in order to identify a primate, we need to make sure that this skull has both forward-facing eyes and a postorbital bar. It can't just have one, it has to have both in order to be a primate. So does anyone have any questions before I move on from these two important traits? Yes,
I do.
Heather.
What is the difference? Like, what is the point of a post-orbital bar?
I'm glad you asked, and I will get to that very shortly. So following that is, why might these two traits be important? And the big theory or the big hypothesis that most people ascribe to is the arboreal adaptation hypothesis. And what this hypothesis states is that primates evolved to live and move around in trees. And because of that, we have a very distinct morphology. One, the forward-facing eyes are incredibly important because they give us stereoscopic vision or depth perception. And can anybody think of why depth perception might be really important when you're moving around in the trees?
Jumping from branch to branch.
Yeah.
Exactly. Yeah, jumping from branch to branch. So if you don't have depth perception and you try to jump to a branch and you miss that branch, then you would fall to your death. And that wouldn't work out very well in terms of evolution and passing on your genetic code. And then also what's very important with this arboreal adaptation hypothesis is the fact that we rely so much on our sense of vision. Primates have terrible senses of smell. We have pretty poor hearing. Our sense of vision is really the thing that helps us move about and through the world. So the postorbital bar is thought to possibly be a protective skeletal feature. So if you get hit in the side of the head, you have this postorbital bar that is going to protect your eye. Essentially, it stops your eye from getting popped out, basically. So it's really important. So we have functional vision so we can function and move through our world.
Is it,
all of this is related to trees.
I have a question, not to interrupt, but like, is it common for an animal like a grizzly bear or horse, or not a horse, they have a postorbital, but for a grizzly bear who doesn't have a postorbital, for them to get their eyes knocked out?
Not typically. So the ones that we see with forward-facing eyes but no postorbital bar are carnivores. They're usually apex predators, and they're oftentimes larger animals that really don't have to worry about being prey.
Okay.
But primates are still very much prey in the animal kingdom. We are not apex predators by any means.
Okay.
So now that we've learned our two features and why we have them, you guys are now graduated to being paleoanthropologists out in the field, and you have found a group of skulls that need to be sorted into primate and non-primate groups. And the first specimen we found is this one. And can anybody tell me if this is a primate or a non-primate?
Non-primate.
Yes, I don't think it has.
Is a non-primate. And why would you say that?
It doesn't have forward-facing eyes.
Doesn't have forward-facing eyes, and it also
orbital.
A postorbital bar. Exactly. So we know specimen 1 is a non-primate. We can stick him in our non-primate pile. What about specimen 2?
That's a lemur or something. That's
Primate.
It is correct. This is a lemur. So great job. You are a wonderful primatologist. And again, why would we classify this as a primate?
Forward-facing eyes and orbital bones.
Perfect. Yes, forward-facing eyes and that postorbital bar. Specimen number 3, primate or non-primate?
Primate.
Primate. Perfect. And again, the same reason, those forward-facing eyes and that postorbital bar. And then our final specimen, is this a primate or a non-primate? Non-primate. Great. Can anyone tell me why?
It's probably an apex predator. It doesn't have the orbital bone.
Great. Yes. Doesn't have the orbital bones, but it does have those forward-facing eyes. And this is actually a fox bat or a fruit fox bat, something like that.
Oh.
Yeah, it's a bat. Isn't that fun? Great. So are there any questions before we wrap up today's lecture?